Hey everyone, welcome back to my YouTube channel. I'm Chavi Shastri and I'm here with a new video on the topic dimension reduction. This will cover how we will identify multicollinearity in Python, how we will apply principal components analysis using Python. So, what is dimension reduction? Dimension reduction in data science refers to the process of reducing the number of features or variables in a dataset while retaining as much relevant information as possible. It is a critical technique for simplifying data analysis, improving model performance, and enhancing interpretability. High dimensional data can be challenging to work with due to increased computational complexity, potential overfitting, and the curse of dimensionality, which is a phenomenon where the volume of the feature space grows exponentially, making data sparse and harder to analyze. So, types of dimension reduction include feature selection, which identifies and retains only the most relevant feature while discarding others. Methods of feature methods of feature selection includes filter methods, which use statistical measures, for example, correlation, mutual information to score and select features. Wrapper method include use machine learning models to evaluate subsets of features, for example, recursive feature elimination. Embedded methods perform feature selection as part of the model training process. Now, the second type is feature extraction, which transforms data into a lower dimensional space by creating a new feature that summarizes the original ones. Its methods include principal component analysis, which is projects data onto a lower dimensional space by maximizing variance. Linear discriminant analysis focuses on maximizing class separability. TSNE, a non-linear technique for visualizing high-dimensional data in 2D or 3D. Autoencoders include neural networks that learn compressed representation of data. So why use dimension reduction? There are four reasons. Because dimension reduction improved model performance, data visualization, better interpretability, and handling multicollinearity. So, challenges in dimension reduction are loss of information. Reducing dimensions may lead to a loss of significant data feature, interpretability, extract features, PCA components may not have a clear interpretable meaning. Parameter tuning nonlinear method like TSNE often requires careful parameter tuning for effective results. By reducing dimensions effectively, data scientists can make datasets more manageable, enhance model reliability, and uncover meaningful insights more efficiently. So, understanding multicollinearity causes and consequences. So, causes of multicollinearity is multicollinearity arise when independent variables in a regression model exhibit high correlation, making it difficult to isolate the individual influence of each variable. This offer this often occurs when using variables that share similar underlying factors or are derived from the same sources. Consequences of multicollinearity is the presence of multicollinearity can inflate standard errors, leading to inaccurate p-values, unreliable parameter estimates. It also makes it challenging to interpret the significance and direction of individual predictor variables. Detecting multicollinearity. There are two methods, correlation matrix and variance inflation factor. Correlation matrix visualizing the correlational coefficients between variables. Values close to 1 or -1 indicate strong correlation. VIF is quantifying the extent of multicollinearity for each variable. Values greater than 5 or 10 suggest problematic multicollinearity. Introduction to principal component analysis. This includes three steps. First is data transformation. Second is dimension reduction, and third is feature restriction. PCA is a statistical technique that transforms a set of correlated variables into a smaller set of uncorrelated variables called principal components. This process aims to capture as much of the original data's variance as possible in a reduced number of dimensions. Implementing PCA in Python. This includes four steps. Importing libraries. Start by importing essential libraries such as pandas, numpy, and scikit-learn. Second is load data. Load your data into pandas data frame. Preprocessed data handle missing values and convert categorical variables. Fourth one is scale data. Standardize features to have zero mean and unit variance using standard scaler. Determining the number of principal components. This includes two methods. One is elbow method and second is screen plot. Elbow method plot the explained variance ratio against the number of components. Look for an elbow point where the rate of increase in variance slows down. Screen plot displays the eigenvalues of the principal components in descending order, helping visualize the amount of variance explained by each component. Interpreting the principal components and loadings includes loadings and interpretation. Loadings represent the contribution of each original variable to the principal components. High loadings indicate a strong association between the variable and the component. Interpretation analyzing the loading to understand which original variables are most influential in each principal component. Applying PCA for dimension reduction includes reduced dimension. The PCA transformation effectively reduces the number of dimensions while preserving the essential information, enabling better visualization and model building. Improved analysis. Dimensionality reduction allows for easier exploration and analysis, especially for the data with many variables. Now jumping into the coding part. So this is the code for how we will identify multicollinearity in Python. First, we import the libraries. Here we create a function which identifies multicollinearity in a panda data frame. df is the input data frame. Here threshold is the correlation coefficient threshold above which multicollinearity is flagged. This function returns a data frame containing pairs of highly correlated feature and their correlation coefficients. Core matrix is equal to df.core. Calculate the correlation matrix. For extracting upper triangle of the correlation matrix, we use this command. This code is for find pair of features with correlation coefficient above the threshold. So this is example usage of identifying multicollinearity. Here I have taken a sample data. You can replace it with your actual data. So we are running this code. And this is the output for this code. We get feature 1, and feature 3 in feature 1 column. In feature 2 column, we get feature 3, target and target. In correlation column, we get 1.0, 1.0 and 1.0 in all the rows. And this is the code to apply principal component analysis using Python. First, we import libraries. Here I have taken a sample data. You can replace it with your actual data. For separating features from the target variables, we use this command. Then we standardize the feature by using those commands. These are the commands to apply PCA. Now we create a new data frame with PCA components and then explain variance ratio and finally print the PCA data frame. So on running this program, we will get this output. So this is all about the regression. This is all about the dimension reduction. Thank you guys.